Next class, that is the multinomial theorem. Okay, see, that is x1 plus x2 plus and so on xm whole power n equal to, that is sigma k1 plus k2 plus and so on plus km equal to n, that is n in of k1 k2 and so on km, that is x1 power k1, x2 power k2 and x3 power xm power km. Okay, it is the multinomial theorem. See, in mathematics, the multinomial theorem says how to write a power of a sum in terms of power of the terms in that sum. It is the generalization of the binomial theorem to the polynomials. It is the generalization of the binomial theorem to polynomials. Next, for any positive integer m and any non-negative integer n, the multinomial formula tells us how a polynomial expands when raised to an arbitrary power. Okay, for any positive integer m and any non-negative integer n, the multinomial formula tells us how a polynomial expands when raised to an arbitrary power. Okay. See, what is the coefficient of x cube y power 7 in x plus y whole power 10? That is the coefficient of x cube y power 7 equal to, that is 10 factorial n factorial by coefficients is 3 factorial and 7 factorial, that equal to 120. Okay, so the coefficient of x cube y power 7 equal to 10 factorial by 3 factorial 7 factorial, that equal to 120. Next, x plus 5 whole power n equal to n0 x power n y0 plus n1 x power n minus 1 y power n plus n2 x power n minus 2 y square plus n3 x power n minus 3 y3 plus and so on plus n minus 1 x power 1 y power n minus 1 plus n x0 y power n. This is the x power y whole power n, that equal to n0 x power n y0 plus n1 x power n minus 1 y1 plus n2 x power n minus 2 y2 plus n3 x power n minus 3 y3 plus and so on plus n minus 1 x power 1 y power n minus 1 plus n x0 y power n. Next, principle of inclusion and exclusion. Okay, principle of inclusion and exclusion. See, the sum rule which is applied to the non-disjoint sets. Okay, the sum rule which is applied to the non-disjoint sets is called principle of inclusion exclusion. It is also called as CV method. CV method. Okay, the sum rule which is applied to the non-disjoint sets is called principle of inclusion exclusion. It is also called as CV method. Okay, statement: if A and B are two subsets of any set, then modulo of A union B equal to module A plus module B minus module A intersection B. If A and B are two subsets of any set, then A union B equal to modulus A plus modulus B minus A intersection B. If A, comma B and C are three subsets of any set, Then we have A union B union C modulo equal to modulo of A plus modulo of B plus modulo of C minus modulo of A intersection B minus modulo of B intersection C minus modulo of C intersection A plus A intersection B intersection C. Okay. If the two subset AB minus A intersection B, if 3 A plus B plus C minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. So what is the principle of inclusion? The sum rule which is applied to the non-disjoint sets, it is called as principle of inclusion and exclusion. It is also called CV method. Okay. Next. See, suppose that 200 faculty members can speak French and 50 can speak Russian, and while only 20 can speak both French and Russian. So how many faculty members can speak either French or Russian? So 50 వచ్చేసి 50, 200 is the French and 50 is the Russia. Both are 20. Okay, see, F set of faculty who can speak French or set of faculty who can speak Russian, F intersection or set of faculty who can speak French and Russian. Okay, that is therefore the required number of faculty members that equal to F union R equal to F plus R minus F intersection R, that is modulo of F union R equal to modulo F plus modulo R minus F intersection R, that equal to 200 plus 50 minus 20 equal to 230. So 230 faculty members can speak either French or Russian. This F union R equal to 230 faculty members. Okay, so F equal to French, R equal to Russian, F intersection R both, and required is the F union R equal to F plus R minus F intersection R, that equal to 100 plus 50 minus 20 equal to 230. Next, if there are 200 faculty members that can speak French, 50 can speak Russian, that 100 can speak Spanish, 20 can speak French and Russian, 60 can speak French and Spanish, 35 speak Russian and French, while only 10 speak French, Russian and Spanish. Okay, so how many speak either French or Russian or Spanish? That is equal to F set of faculty who can speak French, capital R, set of faculty who can speak Russian, S set of faculty who can speak Spanish. Therefore, required number of faculty members equal to F union R union S, that equal to F plus R plus S minus F intersection R minus R intersection S minus S intersection F plus F intersection R intersection S, that equal to 200 plus 50 plus 100 minus 20 minus 60 minus 35 plus 10, that equal to 245 can speak either French or Russian or Spanish. Okay. So totally 3, that is F union R union S equal to F plus R plus S minus F intersection R minus R intersection S minus S intersection F, F intersection R intersection S, that equal to totally 245 members can speak maybe either French or Russian or Spanish. Okay. Next. Next problem. A certain computer center employs 100 computer programmers of members can be programmed in Fortran, 35 in Pascal, and 23 can both languages. Okay, in both languages. How many can program neither of these languages? See, totally 100. See, the number of programmers who can program in at least one of the two languages that equal 24 plus 23 plus 12 that equal 59. Then the number of programmers who can program in neither, not either, neither of these two languages, rendu kakunda, that is 100 minus 50 equal to 41 members. That is the 41. Okay. So the number of programmers who can program at least one of the two languages, 24 plus 23 plus 12. Okay. The number of programmers who can program neither of these languages 100 minus equal to 41. See, this is the 20, 12 and ఇది just 24 ఉంటుంది. Okay. So the number of programmers who can speak, like who can program in neither of these two languages, that is 100 minus 59 equal to 41. Okay. Next, let F that is equal to programmers who can in the photon, P programmers who can in Pascal, F intersection P program who can program in Proton Pascal. So the number of programmers who can program in at least one of the two languages that equal F union P equal to F47 P35 minus F intersection P23 that equal to 59. And the number of programmers who can program is neither of these two languages, F intersection P equal to F union P of C equal to U minus F union P that equal to 100 minus 59 that equal to 41. Okay, F dash intersection P dash equal to F union P whole dash that equal to modulus U minus F union P that equal to 100 minus 59 equal to 41. This is 41. Okay. So likewise, we have to construct F P, F union P, F plus P, F is equal to 447. P is the Pascal 35 minus both are 23. So it is the 59. See here. 59. Next, the number of programmers who can program is neither of these two languages. F intersection P equal to F dash intersection P dash equal to F union P whole dash that equal to modulus U minus F union P that equal to 100 minus 59 equal to 41. Okay. Next, how many integers in the set 1 comma 2 comma 3 and so on 1000 are not divisible by 2 or 3 or 5? See solution. N of 2, the number of integers in the set that are divisible by 2. N of 3, number of integers in the set that are divisible by 3. Number of integers in the set that are divisible by 5, and n of 2 union 3 5 equal to n of 2 plus 3 plus 5 minus 2 intersection 3, n of 3 intersection 5, n of 2 intersection 5 plus n of 2 intersection 3 intersection 5 that equal to n of 2 1000 by 2 500, n of 3 1000 by 3 333, n of 5 1000 by 5 200, n of 2 intersection C that equal to 1000 by 2 into 3 166, n of 3 intersection 5 that is 1000 by 15 equal to 66, n of 1000 by 10 that equal to 100, n of 1000 by 30 33. Okay, see. N of 2 intersection 5 100, 2 3 5 33. Then therefore n of 2 union 3 union 5 equal to 500 plus 33 plus 200 minus 166 minus 66 minus 100 plus 33 equal to 734. Therefore required number of integers equal to 1000 minus 734, that equal to 266 members are required. See here. Not divisible by 2 or 3 or 5 is 266. So how to calculate? First we have to division of 2, division of 3, division of 5, division of 2 intersection 3, 3, 5, division of 2, 5 and division of 2, 3, 5. Then total is 500 plus 300 plus 200 minus 66 minus 166 minus 100 equal to 734. Not divisible by equal to 1000 minus 734 equal to 266. These are the 2 or 3 or 5. Okay. Next. D arrangements. Okay. Among the permutation of set 1 comma 2 comma and so on, there are some called D arrangement in which none of the n integers appear in its natural place, that equal to Dn equal to the number of D arrangement of n elements, that equal to n factorial equal to 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by and so on plus minus 1 whole power n by n factorial. Okay. So Dn equal to the number of D arrangement of n elements n factorial of 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial and so on minus 1 whole power n by n factorial. Okay. Next one. So 5 balls marked which B1, B2, B3, B4, B5 are be kept 5 cells marked with C1, C2, C3, C4, C5. In how many ways this can be done so that ball B1 is not kept in cell of Ci, that is I equal to 1, 2 and so on 5. See, required number of phase D5 is equal to 5 factorial minus 1, 2 factorial minus 1 by 3 factorial minus 1 by 4 factorial plus 1 by factor, that is 60 minus 20 plus 5 minus 1, that equal to 44. Okay, so 5 balls marked with B1, B2, B3, B4, B5 are to be kept into 5 cells marked with C1, C2, C3, C4, C5. In how many ways this can be done so that the ball B1 is the kept in the cell is, that is 5 factorial, that is 1 by 2 factorial minus 1 by 3 factorial minus plus 1 by 4 factorial minus 1 by 5 factorial. Okay, is equal to 44. Next. For students take a quiz, then for the purpose of grading, the teacher asks the students exchange paper so that no one is grading his own paper. How many ways this can be done? That is the D for 4 factor, that is the 1 by 2 factorial minus 1 by 3 factorial minus 1 by like plus 1 by 4 factorial. Okay. So 2 factorial, 3 factorial plus 4 factorial equal to 12 minus 4 plus 1, that equal to 9. Next. The pigeonhole principle. Suppose a flock of pigeons fly into a set of pigeonholes to roost. If there are more pigeons, then there must be at least one pigeonhole that has more than one pigeon in it. Okay. If k plus 1 or more objects are placed into k boxes, then there is at least one box containing 2 or more of the objects. Suppose a flock of suppose a flock of pigeons fly into a set of pigeon holes to roost. If there are more pigeons than the pigeon holes, then there must be at least one pigeon hole that has more than one pigeon in it. If k plus 1 or more objects are placed into k boxes, then there is at least one box containing two or more objects. Okay. See, in a group of 367 people, there must be two people with the same birthday. Okay, as there 36 possible of birthdays. In group of 27 English words, at least two words must start with the same letter. That is, only 26 letters are possible. As there are only 26 letters are possible. Okay. See, if capital N objects are placed into K boxes, then there is at least one box containing N by K objects. Okay, if N objects are placed into K boxes, then there is at least one box containing N by K objects. This is the theorem of 2 in the textbook. Okay, see. So the pigeonhole principle is, suppose a flock of pigeons fly into a set of pigeonholes to roost. If there are more pigeons than pigeonholes, then there must be at least one pigeonhole that the same more than one pigeon. So number of pigeons ఉంటాయి, కంపల్సరీ ఒక pigeon ని ఒక holes లో assign చేయాలి అని చెప్తాం. ఓకేనా? There are more pigeons in pigeon, but at least one pigeonhole that must into the one pigeon in it. If k plus 1 or more objects are placed into k boxes, then there is at least one box containing two or more objects. Okay. That is the next one. In a group of 367 people, there must be two people with the same birthday. That is, there are 366 possibles. In a group of 27 English words, at least 26 letters. And it is one of the theorem in the textbook. If n objects are placed into k boxes, then there is at least one box containing n by k objects. Okay. We'll see tomorrow. Thank you. Next one. Thank you.